All right, let's dive in. Today, we're going to shrink down way down into the world of the atom. And we're going to find a little bit of beautiful mathematical order in what seems like just pure chaos. We're going to uncover the simple, elegant rule that tells every single electron exactly where it's supposed to be. I mean, seriously, think about it. You've got this tiny little nucleus, and then all these electrons are just buzzing around it like crazy. How do they stay organized? I mean, why isn't it just total, absolute chaos? Well, it turns out nature has a system, a really good one. Okay, so the best way to get your head around this is to picture a huge stadium. Right in the middle, you have the stage. That's the nucleus. And all the electrons, they're the audience. But here's the thing. They can't just sit wherever they feel like. They have specific assigned seating levels. Now, in the world of chemistry, we don't call them seating levels, of course. We call them shells. They start really close to the nucleus and just move outwards. The first shell is the K shell. The second is L. Third is M. Fourth is N. And it just keeps going. Simple enough, right? But the real question is, how many electrons can fit in each one? And this is where the magic happens. The number of seats in each level isn't random at all. It's all governed by this really elegant, simple little formula called the 2n² rule. This is what tells us the absolute maximum number of electrons that are allowed in any single shell. It's kind of like the secret code to the whole atomic structure. So let's break this thing down. What does it all mean? Well, it all starts with n. And honestly, this is the easiest part. N is just the number of the shell you're talking about. So for that first shell, K, N is 1. For the second one, L, N is 2. For the third, N is 3. You see the pattern? The next piece of the puzzle is to take that shell number, N, and you just square it. You multiply it by itself. Now, this little step is super important because it means the farther you get from the nucleus, the more the capacity just explodes. It grows really fast. And for the final step, you just take that number and double it. That's it. That is the entire secret sauce. 2 times the shell number squared, 2n squared. And that gives you the maximum number of electrons for that shell. Simple as that. Okay, theory is one thing, but let's actually put this to the test, right? Let's start with the very first shell, the K shell. For this one, our n value is 1. So we just plug it in. We've got 2 times 1 squared. Well, 1 squared is just 1, and 2 times 1 is 2. That's it. So think about this. That first shell, the K shell, can only hold a maximum of 2 electrons. Period. It's like the super exclusive front row with only 2 seats available. All right, let's move out to the next level, the second shell. That's the L shell. So for this one, our n is, you guessed it, 2. Okay, let's run the formula. 2 times 2 squared. 2 squared is 4, so 2 times 4 gives us 8. So the L shell can hold up to 8 electrons. See? You can already feel how things are getting a bit more spacious as we move out from the center. Okay, I bet you're getting the hang of this now. Let's keep this ball rolling. We're moving out to the third shell, the M shell, which means our n value is 3. So what's the math? 2 times 3 squared. Well, 3 times 3 is 9, and you multiply that by 2, and you land on 18. Wow. So the third shell can pack in a maximum of 18 electrons. That is a pretty big jump from 8, right? Okay, let's do one last one just to really lock this in. We're going out to the fourth shell, the N shell. So here, N is going to be 4. All right, last time through the formula. 2 times 4 squared. 4 times 4 is 16, and 16 times 2 is 32. The N shell has room for a whopping 32 electrons. I mean, the space really opens up the farther you get from that center space. And here, look at this. This table just lays it all out perfectly. You can see it all lined up. The shell, the N value, the simple calculation, and that final number. 2, then 8, then 18, then 32. It's just this perfect, predictable pattern, all thanks to that one little rule, 2n squared. So, okay, who cares, right? Why does this atomic seating chart even matter? Well, it matters because pretty much all of chemistry hinges on this. That number of electrons in the very outermost shell, that dictates everything about how an atom behaves. It's what makes it bond with other atoms to create water or salt or, well, you. It's the reason the whole periodic table is shaped the way it is. It's absolutely fundamental. So if there's one thing you walk away with, let it be this formula. The maximum number of electrons is 2n squared. It's the simple, beautiful piece of math that brings perfect order to the entire atomic universe.
And it kind of makes you wonder, doesn't it? If the building blocks of everything are governed by such a simple, elegant rule, what other amazing, simple rules are out there, just hiding in plain sight, bringing order to what looks like a totally chaotic universe? It's something to think about.